Hello everyone. In this video, we will explain what is a polynomial of single variable and what is the leading coefficient, what is the monic polynomial, constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial, and what is a zero of a polynomial, what is the root of a polynomial equation, and what is the division rule, and what is the remainder rule, etc. All these will be explained in detailed way along with a few examples. This chapter polynomial 2 is very important to study quadratic equations or solving of polynomial equations or wherever it comes. These are very helpful. I have explained in polynomial 1 that what is an algebraic expression. An algebraic expression is the sum of monomials. Monomial means it is the product of real numbers or letters representing constants and variables with non-negative integer powers. Right. You can take one variable, two variables, three variables, any number of variables. But here, polynomials of single variable, we study much more than polynomials of several variables. So what is a polynomial of single variable, right? So here an expression f of x equal to a naught plus a1x plus a2x square plus and so on plus an into x to the power of n. So it is nothing but sum of monomials in a single variable. Right. Where what do you call a naught, a1, a2 and so on, an? They are known as real constants. Real constants known as coefficients. Right. This is known as a coefficients. And what do you call n? What do you call this n? Okay. Here n is greater than or equal to 0 and n belongs to z. Or you can say that n is a non-negative integer. N is a non-negative integer. Remember, the power must be a non-negative integer. It should not be a rational number or irrational number. Non-negative integer known as what do you call degree? Known as degree. It is a degree. It is also a degree if an is not equal to 0. That's coefficient of x power n. So it is an nth degree polynomial equation provided an not equal to 0, where and x is a variable. X is a variable. In place of x, you can write any letter. Not only x, in place of x, you can write y, z, t, whatever you want, you can replace. So a polynomial means it is the sum of monomials, or simply in the form of a naught plus a1x plus a2x square plus an x to the power of n, where a naught, a1, a2 and so on an are real constants. They are specifically known as a coefficients. And n is called degree of the polynomial. Degree of the polynomial. So you can create several examples by your own. For example, Here I am giving one example. Two x square plus 3x minus 2 is a polynomial. Is a polynomial. Of degree how much? Of degree 2. Of degree 2. Of degree 2. This is one example. In this way, you can create several examples. If you want, I can write another one. That t cube minus 3t plus 4 is a polynomial of degree 3. Here you see this power. Degree is 3. You can write the polynomial in any variable. U to the power of 4 minus 2u square plus u plus 5 is a polynomial of degree 4. Now, specifically, what do we call this an? What do you call this an? An is known as leading coefficient. This is known as a leading coefficient. Leading coefficient. So if leading coefficient equal to 1, if leading coefficient equal to 1, so if an equal to 1, if the leading coefficient is 1, then f of x is called a monic polynomial. F of x is called f of x means here the polynomial is called a monic polynomial. Monic. Mon means 1. Monic polynomial. Well, I'll give you an example. So here I'll give you an example okay, here x cube minus x square plus 5x plus 6. So here x coefficient of the highest power of x is 1, right? So it is a monic polynomial. Is a monic polynomial. A monic polynomial. Here the leading coefficient is 1. Here the leading coefficient is 1. This is known as a leading coefficient. This is known as a leading coefficient equal to 1. Means the coefficient of highest power of x. Here is an example. Find the degree and the leading coefficient of the polynomial. Find the degree and the leading coefficient of the polynomial. Remember here, this highest power is 6. So this is known as a degree. So here the degree equal to 6. And whereas the coefficient of t power 6, coefficient of t to the power of 6, t to the power of 6 equal to, what is the coefficient of t power 6? That is minus 5. Equal to minus 5, it is known as a leading coefficient. This is called leading coefficient of the polynomial. Leading coefficient of the polynomial, of the given polynomial. Now, I'm going to explain what are the types of polynomials. So now you understand that what is a leading coefficient of a polynomial, what is the degree of the polynomial, and what is the monic polynomial. Now, I'll give you an example which are not at all polynomial. Once again, I will remember you that the power of variable in each term must be non-negative integer. The power of variable in each term must be a non-negative integer. See here, for example, root x. X to the power of 1 by 3 plus 5x to the power of 1 by 4. X square plus x minus cubed root of x are not polynomials. Are not polynomials. They are not polynomials. Why they are not polynomials? Because they are not polynomials. Because the power of the variable are not non-negative integers. Here the power is 1 by 2. 1 by 3 here is the power. And here the power is 1 by 4. Even though here the power is 2 and here the power is 1, but in another term, the power is 1 by 3. Here in this, the power equal to 1 by 3. In this term, power of x equal to 1 by 3, which is not a non-negative integer. So that's why these are not polynomials. Now, what kinds of polynomials we have? Like constant polynomial, linear polynomial, quadratic polynomial, and what is a zero polynomial, etc. I'll explain now. Well, so here in this polynomial, what is a constant polynomial? A constant polynomial means that polynomial will contain only single term, which is a constant without a variable x, without a variable simply. So here I can write that f of x equal to some constant a not equal to 0 or not necessary. Okay. This is a non-zero constant polynomial. A is a constant. Here a is a constant. A is a constant. And what is the degree? Here the degree of this polynomial equal to 0. You can say a into x to the power of 0, where a is not equal to 0. It's a constant polynomial. F of x equal to, you take 1. F of x equal to, you take some minus 2. F of x equal to, you take, these are all known as a constant polynomials. Now, what is a linear polynomial? Linear polynomial means it will contain only degree 1. So this is equal to ax plus b. Ax plus b, where a is not equal to 0. So for this, what is degree? The degree equal to 1. So a polynomial with degree 1 is called a linear polynomial. For example, you can take that f of x equal to x. And f of x equal to, you can take some minus 2x plus 3. Well, in this way, you can create by yourself. These are all known as linear polynomials. It is not necessary to write only in terms of x. You can write it in any variable like minus the u minus 4, like this. Or instead of x, I am writing here u. Now, what is a quadratic polynomial? A quadratic polynomial means the degree must be equal to, f of x equal to ax square plus bx plus c. Right? So here a is not equal to 0. it is known as a quadratic polynomial. And what is the degree of this quadratic polynomial? Degree equal to 2. Okay. So I can give you some examples like f of x equal to, you take that x square plus 1 is a quadratic polynomial. Or I can write f of t equal to 2t square minus 3t. It is a quadratic polynomial. Well, now what is a cubic polynomial? What is a cubic polynomial? What is a cubic polynomial? A cubic polynomial means the degree of the polynomial is 3. So I can write that ax cube plus bx square plus cx plus d. So here you must take care that where a is not equal to 0, unless otherwise we say that a, b, c, d are all real constants. So here what is the degree of this polynomial? Degree of this polynomial equal to 3. Degree of this polynomial equal to 3. So a polynomial of degree 3 is known as a cubic polynomial. So I can give you a simple examples of this. F of x equal to, you can take only x cube, or I can write that f of t equal to minus 2t cube plus 3t plus 5. You can write in any variable, or I can write that f of u equal to 5t cube plus 6t square minus 8. So these are all known as cubic polynomials. Now what is a biquadratic polynomial? What is a biquadratic polynomial? A biquadratic polynomial means the degree of this polynomial equal to 4. So I can write ax to the power of 4 plus bx cube plus cx square plus dx plus e. So here what is the degree? The degree of this polynomial equal to 4. Of course, where a is not equal to 0. So now here the space is not sufficient. So now I will write separately. What is a zero polynomial? Zero polynomial means every term in the polynomial is 0. Means every coefficient must be 0. And the degree of the zero polynomial is not at all defined. Okay. So I'll write what is a zero polynomial. So zero polynomial means every term in the polynomial is 0. F of x equal to 0 plus 0 into x plus 0 into x square, okay, plus and so on. There is no end at all. So simply we write this is equal to 0 is called a zero polynomial. So what is the degree of a zero polynomial is not defined. It's a zero polynomial whose degree is not defined. Whose degree is not defined. So it has no finite degree. So once again, zero polynomial means it contains all zeros. So if you add a zero polynomial to any polynomial, you will get the same polynomial. Well, so here I am writing that if you add a zero polynomial to any polynomial, like for example, g of x plus 0 equal to, you will get simply g of x. where g of x is a polynomial. Where g of x is a polynomial. Now, what is the value of a polynomial at a given x? What is the value of a polynomial at a given x? After that, I will define what is 0 of a polynomial, what is the root of a polynomial, and the difference between root and 0. Here, let f of x and g of x be two polynomials. Then the sum, f of x plus g of x, the difference, f of x minus g of x, the product, f of x into g of x, the nth power of a polynomial. These are all polynomials. Are all polynomials. So sum of two polynomials is a polynomial. The difference of two polynomials is a polynomial. The product of two polynomials is a polynomial. And the integer power of a polynomial is also a polynomial. Well, how do we find out the value of a polynomial at x equal to alpha? It is important. Based on this fact, we can define the 0 of a polynomial. So, to find the value of a polynomial f of x at x equal to alpha means directly substitute this alpha in the given variable x. So here I am writing the value of f of x at x equal to alpha. The value of f of x at x equal to alpha is simply f of alpha. Means in place of x, we just write the number alpha. Alpha is a number. For instance, I'll give you an example. The value of f of x equal to, you take that 2x square minus 3x plus 5 at x equal to minus 2 is dash. So what is the value of at x equal to minus 2? So here is the answer that the value of f of x at x equal to minus 2 is simply substitute the value minus 2 in place of x. So here f of minus 2. Simply they are asking what is f of minus 2. 2 into minus 2 whole square minus 3 into minus 2 plus 5. This is equal to minus 8 plus 6 plus 5 equal to 3. So the value of f of x at x equal to minus 2 is 3. I'll give you another example. Let f of x equal to x cube minus 6x square plus 11x minus 6. I am asking what is the f of 0? Means the value of f at x equal to 0. So the value of f at x equal to 0 means substitute this 0 in place of x. So you will get here, you see 0 cube minus 6 into 0 square plus 11 into 0 minus 6. You will get minus 6. This is the value of f of x at x equal to 0. Similarly, what is f of minus 1? Substitute here. Minus 1 whole cube is minus 1. Minus 6, minus 11, minus 6. This is equal to minus 24. Now, what is f of 1? F of 1 equal to 1 minus 6 plus 11 minus 6 equal to 0. So here the value of f of 1 is 0. The value of f of 1 is 0. Similarly, what is f of 2? You will have 8 minus 24 plus 22 minus 6 equal to. This is 30, 30 is 0. What is f of 3? This is 27 minus 54 plus 33 minus 6 equal to. This is 60 and this is also 60 equal to 0. Here, at some values, the value of f vanishes. Vanishes means it becomes 0. At some values, the function or the expression, polynomial expression, vanishes means becomes 0. Then what do you call these? So in these expressions here you see we have got that at 1, 2, 3 the polynomial becomes 0. So these 1, 2, 3 are known as zeros of the polynomials. So here x equal to 1, 2, 3 are known as the zeros. The zeros. Remember, many students do not know the difference between zeros and roots. So the zeros of f of x equal to x cube minus 6x squared plus 11x minus 6. Now you may have understand that what is the zero of a polynomial. To call a number is a zero of a polynomial, we must have that polynomial value is 0 at that given value. So I'll write here what is the zero of a polynomial. Well, a real number alpha is called a zero of a polynomial f of x if the value of the polynomial at alpha equal to 0. The polynomial value at x equal to alpha is a 0. When you plug x equal to alpha in the polynomial, if it vanishes, then it is called a zero of the polynomial. For example, you take f of x equal to 2x minus 1. Well, at what value that f of x will vanish, right? So here f of x equal to 0. We want that equal to 0. So 2x minus 1 equal to 0. So that x equal to 1 by 2. At x equal to 1 by 2, that value vanishes. So therefore, x equal to 1 by 2 is called the zero of f of x equal to 2x minus 1. So remember, simply the zero of a polynomial means at what values that polynomial vanishes. At what value the polynomial vanishes. I'll give you one more example. Find all zeros of the polynomial. Find all zeros of this polynomial. Well, we want all the zeros of this polynomial. See, it is a fourth degree polynomial because t square into t square is t to the power of 4, right? So it must have 4 zeros. It must have 4 zeros. So to find the zeros of to find the zeros of f of t, right? We must take we take that f of t equal to 0. For what values of t this polynomial will become 0. So which means that t square minus 1 into 4t square minus 3 equal to 0. This is a product AB equal to 0, either A equal to 0 or B equal to 0, right? So product of two terms will be 0 if at least one of them is 0, otherwise it cannot be. So this implies this t square equal to, this I can write t minus 1 into t plus 1, well, equal to 0, or this I can write 2t minus root 3 into 2t plus root 3, a plus b into a minus b, equal to a square minus b square. So this we get t equal to either minus 1 or plus 1 minus 1, or from the second one you will get t equal to either this is 0 3 by 2 or this is 0 minus root 3 by 2. So we got 4 zeros. So therefore t equal to, you can say, plus or minus 1 plus or minus root 3 by 2 are the zeros of are the zeros of f of x, or the zeros of the polynomial f of x. So remember, if f of x is a linear polynomial, it will have only one zero. If f of x is a quadratic polynomial, it will have two zeros. If f of x is a cubic polynomial, it will have three zeros, whether they are equal or coincident or equal. A quadratic polynomial will have four zeros. An nth degree polynomial will have n zeros. These n zeros need not be real. They may be real or complex. The complex you will learn in higher classes. So I'll write that point clearly. So every nth degree polynomial f of x equal to a naught plus a1x plus and so on, an explore an not equal 0 will have n zeros. So the number of zeros of a polynomial equal to the degree of the polynomial. The number of zeros of a polynomial equal to the degree of the polynomial. Now, many people or many students may misunderstand that if a polynomial is repeated, then we do not count. But that is absolutely wrong. Here you see that one example I'll give you. the zero of f of x equal to x is simply 0, right? The 0 of f of x equal to x is a 0 in bracket since f of 0 equal to 0. The zeros of f of x equal to, here f of x is not necessary. Zeros means it will have more than one. Okay. F of x equal to x squared. Okay. Here or you say 0, 0. Don't write only one term. So the number of zeros of a polynomial equal to the degree of the polynomial. Here, what is the degree? Degree is 2. So the degree is 2. So therefore, it must have 2 zeros. Similarly, the number of zeros or the zeros of f of x equal to, you take that x minus 1 whole cube. So the zeros of this polynomial are 1, 1, 1. In bracket, I'll write since f of 1 equal to 0. Right? Even though they are repeated, but you must say what are the zeros of a polynomial? 3, 1, 1, 1. The number of zeros of the polynomial equal to the degree of the polynomial. Now, what is a polynomial equation and what are the roots of polynomial equation? So, what is the polynomial equation? Let f of x equal to a0, a1x plus a2x square and so on, an x power n be a polynomial of degree n, right? Then f of x equal to 0 is called a polynomial equation. It's called a polynomial equation. So we know clearly that when an expression equal to 0, then it is called an equation. So if a polynomial expression equal to 0, then it is a polynomial equation. For example, f of x equal to ax plus b, right, equal to 0 is a polynomial equation. Is a polynomial equation. Polynomial equation where a is not equal to 0. It is a linear polynomial, right? Similarly, f of x equal to, you take ax square plus bx plus c equal to 0 is a polynomial equation, right? A not equal to 0. The first one is linear, the second one is a quadratic. Similarly, you can take ax cube plus bx square plus cx plus d equal to 0 is a polynomial equation of degree 3, like this. So in place of these constants or coefficients a, b, c, d, etc., you can take any real numbers, right? So if you take a numerical values, let us take 2x square minus 3x minus 1, right? Or you can take a plus 1 is a polynomial equation. Is a polynomial equation. Now, what is a root of a polynomial equation? Right. Here you see, if you take an example, f of x equal to, you take like 2x plus 3 equal to 0. This implies x equal to, we get minus 3 by 2. Or you can say the value of f at minus 3 by 2 equal to 0. Means at that particular value, that equation satisfied. Equation is satisfied. So this minus 3 by 2 is called a root of f of x equal to 0. I'll take another example. You take that f of x equal to, for example, x squared minus 5x, okay, and plus 6 equal to 0. It is an equation, right? It is a quadratic equation. Now, what are the roots of this quadratic equation? Well, for this, we need to factorize this, that this I can write x squared. This 6 I can write minus 3 into minus 2. Of course, here 1. The product of 6 and 1 is 6. And further I can write minus 3 minus. So, x squared, this is minus 3x minus 2x. Whatever numbers I have taken here, those I will write here, plus 6 equal to 0. So, you take here 1x common, x into x minus 3. You take here minus 2 common, then you will have x minus 3 equal to 0. Well, now further we can take a common, that x minus 3 is common. So x minus 3 into, now here x is left, here minus 2 is left. So I can write x minus 2 equal to 0. This implies either x equal to 2 or 3. So which means that at these values, that equation satisfied. So here that f of 2 equal to 0 and f of 3 equal to 0. So therefore, x equal to 2 comma 3 are known as, are the roots. You can say what is this, are the roots of the equation f of x equal to x squared minus 5x plus 6. So there is a difference between root and 0. The 0 term will be used for a polynomial, whereas the root is used for an equation, right? So we will use the word root for an equation, 0 for a polynomial. So what is the 0 of a polynomial? Once again, I am bringing back here. Here I have stated that a real number alpha, okay? It is not necessary a real number. It can be a complex number also. A real number or a complex number. Or a complex number. Because we will learn this complex number in future. So, but anyway, to give a precise definition, that a number x equal to alpha is sufficient, whether it is a real or a complex. So, if 8th class students or 9th class students following this, need not to worry about this complex number. You just think about a real number. So, what is here? A root, right? So, x equal to alpha is called, x equal to alpha is called a root, of f of x equal to 0. Of f of x equal to 0. This is an equation. If that when you plug that alpha in the equation, it must be vanished. So therefore, zeros will be used for polynomial, roots will be used for equation, right? Zeros will be used for a polynomial, whereas roots used for equations. So in the next session, I will explain what is a remainder theorem and what is the remainder when a polynomial is divided by another polynomial. At the same time, how do we do the division of two polynomials? The number of the number of roots the number of roots of a polynomial equation of a polynomial equation is equal to the degree of the polynomial equation. The degree of the polynomial equation. Okay. So every nth degree polynomial equation will possess n roots. So every nth degree polynomial equation possesses n roots. Every nth degree polynomial equation, how many roots? N roots. So quadratic polynomial will have 2 roots. Cubic polynomial will have 3 roots. Biquadratic polynomial will have 4 roots. Fifth degree polynomial equation will have 5 roots, etc. Thank you. Please subscribe my channel and like my channel. And I'll upload all previous JEE main question solutions and previous JEE advanced along with this basic level questions.